Hey guys, it's Mrs. Marquette, and today we're starting chapter 7. So, chapter 7 is all about nth roots. So, in the last chapter, we talked about square roots and the fact that the square root of 4 is equal to 2 because 2 times 2 is equal to 4. What we're going to do today is just expand that to things like third roots and fourth roots and fifth roots and nth roots, meaning that that n could be any number. So we can zoom in here and say 2 is a cube root, cube meaning 3 of 8, because 2 times itself 3 times is 8. So 2 times 2 times 2 is that 8. We can say that 3 is a fourth root of 8, or of 81, because 3 to the fourth is 81. So 3 times 3 times 3 times 3. So then in general, for n is an integer greater than 1, we have b to the n equals a, then b is an nth root of a, meaning if I've, again, got some number to a power equaling a, then I can talk about an nth root. Here's a little notation for us. This nth root, notice that it's a small number. It's in the little crook of that square root, and that's going to be our nth root of a is how we read that. Another way we can write this is a to the power of 1 over n. Here the power of a is 1 and n is just the root. So a couple rules about our nth roots. So n is going to be our root. So if n is odd, so an odd root, then a has one real nth root. The reason for this is because if we have something like the third root of 8, that could maybe be plus or minus 2, but if we check, 2 times 2 times 2 is definitely 8, but 2 times 2 times, or negative 2 times negative 2 times negative 2 is definitely not 8. So we can't say that we have a plus or minus in that situation. However, when n is even, so it's an even, again, root, and a is greater than 0, then a has 2 nth roots. So that's like when I've got the square root of 4, I've really got plus or minus 2, because 2 times 2 is 4 and negative 2 times negative 4. So this being even or odd is going to make a really big difference for us. And then the last thing happens, or talks about, when we have a is equal to 0 and when a is less than 0. So when a is less than 0, then I have no real nth roots. What that means is that I have 2 and then negative 8. Remember that we talked about how if there's a negative under a square root, then we have an I. So that would be the square root of 8i, or 2 times the square root of 2i. We're not going to worry about any of the complex solutions in this chapter. There's going to be no i's. So we're just going to kind of deal with these first two mainly. So let's see kind of what that looks like in these problems. So I have, find the real nth roots of a. So the thing to do, real nth roots of a, is just to write it out. So n is 3, that's the nth root, and a is negative 125. How I write this is the nth root of a. And then I've got to think, what times itself 3 times gives me negative 125? And that is negative 5. I also want to show you this in your calculator. So if you, in your calculator, want to do negative 125 to the 1/3, we're going to do parentheses, negative 125, close the parentheses, and then to the 1/3, where that 3 is the root. So the caret on your calculator is going to let you put that 1/3 into the exponent. So do that caret and then parentheses, 1/3, so 1 divided by 3, and close the parentheses. Hit enter and we do get negative 5. So again, that's a negative, so that's here, 125, all in parentheses. Hit the caret, that's right here, and then 1 divided by 3. So even if you have a different kind of calculator, you should be able to find that caret. If you can't, let me know. Just want to look at the iPad. Here are the keystrokes for plugging that in. So negative 125 in parentheses, caret, 1 divided by 3. And you should still get negative 5. So we'll try that with 2. The nth root of a. So nth 4 root of 16. So I think what times itself 4 times gives me 16. The answer to that is 2. But this is an even root, so I gotta remember that a positive 2 times a positive 2 times a positive 2 times a positive 2 will work, or 4 negative 2's because we have an even number of those negatives. Let's try plugging this one straight into our calculator. I have the nth root of negative 32, and if I plug that in, I can also say that this is negative 32 to the 1/5, or in my calculator, negative 32 in parentheses, caret, 1 divided by 5. You should get negative 2 when you plug that in. The reason that we're not going to have a positive 2 is because if we multiply 2 by itself 5 times, we're going to get a positive 32. So it's all about this one, the little root. And last but not least, nth root of a, nth root of a, third root of 64. We can do this in our heads, or we can plug it into our calculator. I'm not going to ask you to do one way or the other on your test. You just have to be able to plug it in. So we can expand this a little bit. A rational exponent doesn't have to be in the form 1 over n, so I don't have to have a 1 in the numerator. I could have other powers. I could have a 3 over 2. I could have a negative 1 over 2. But what's always going to happen is we're going to have a to the m over n. The m is always the power, and the n is always the root, every single time. So you can think before when we didn't have a denominator on our power, it was always just a to some power. But now that fraction is going to mean that that bottom number is the root. So we can think about this in 2 ways. If I have a to the 1 over n, so that's the root, and then I have an m, that's going to be our power, I can say that a to the m over n is equal to a to the 1 over n, and then take the mth power, which can be written as the nth root of a to the m. So I can take the root first and then take the power, or I can do it in the other order. I could say that a to the m over n is equal to a to the m raised to the 1 over nth power. Okay, so that means a to the m under the nth root. It does not matter to me which way you do it at all. Usually this top one will be easy for our simplifying. So I'll show you what I mean by that. Number 5 says 9 to the 3 over 2. So this is the 3 power and the second root. So I'm going to write this as 9, the second root, raised to the third power. Okay, that comes from our properties up in the box. A to the m over n is the nth root of a raised to the m. Now I can actually start in the parentheses and simplify. So we know what the square root of 9 is. The square root of 9 is 3. So I can just simplify the square root of 9 to be 3, and then I still have to take the third power. And then 3 to the third is 27. So our final answer is 27. The other thing we could do with these problems is we could type this again into our calculator. I can say 9 caret 2 divided by 3, hit enter, and I should get 27 as long as I've done it correctly. Next one, 32 to the negative 2/5. Again, I'm going to write 32. I've got the negative 2 is the power, and 5 is the root. So I'll put the root first, and then the negative second power on the outside, and I can simplify. The 5th root of 32 we've already done today. That's 2. And then raise that to the negative 2 power. This negative, remember we have to flip and make it a fraction. So this becomes 1 over 2 squared, or 1/4. If you plug this into your calculator, you can do 32 caret -2 divided by 5. You'll get 0.25, and then you can change that into a fraction of 1 over 4. Number 7 says 16 to the 5 halves. Again, power over root. So I've got 16, the square root raised to the 5th power. I know what the square root of 16 is. That's 4 raised to the 5th power is 1,024. So you might need your calculator for that one. I can also just plug it straight into my calculator. I'm not going to ask you to do one way or the other. Then 64. I've got 64. I've got the 3rd root, the 2nd power, negative. The 3rd root of 64 is 4 raised to the -2nd power. This means I'm in the wrong spot. Flip it to a fraction, and I have 1 over 16 because it's 1 over 4 squared. So that's how we can kind of do these by hand. Remember that you can also either check by plugging them in, or you can just straight plug them into your calculator. Now these ones we actually have to evaluate using a calculator. So I want to round to 2 decimal places. Number 9 is the 4th root of 5 to the 3rd power. So the easier way to plug this into my calculator is going to be to write it in rational exponent form, meaning I've got the 5 is the base, and then the power goes on the top of the fraction, and the root goes on the bottom. The thing that I want you to be sure of is that that 5 is a larger number in size, not necessarily the number itself, but this 3 over 4 is just a small exponent up in the top right corner. So if I have 5 3/4 as a power there, that looks like 5 and 3/4, not 5 to the power of 3/4. So just be careful when you're writing. In your calculator, you will type 5 to the 3 divided by 4 and hit enter. We'll do that right now. And we get 3.34. They say round to 2 decimal places, so that's what we'll do. And number 10 is 3 to the 4th in the 3rd power. So again, I've got 3 is the number, and then the power is 4, the root is 3. So I'll do 3 caret 4 divided by 3. Hit enter. I'll get 4.33 this time because I've got to round correctly. So check that one in your calculator because you get 4.326, and that's why we round to 4.33. The last thing we're going to do today is solve some equations using roots. So we've done this kind of thing where we have x squared equals 81. I can take a square root on both sides because square roots and squares cancel each other out, and I get x equals plus or minus 9 because the square root of 81 is 9. Today we're going to do the same exact thing, except when I have a 3rd root, or rather when I have a third, when I've got x cubed equals 27, I can take a 3rd root on both sides because 3rd roots are going to cancel powers of 3, and 4th roots are going to cancel powers of 4, and 5th roots are going to cancel powers of 5, and so on and so forth. So then x is equal to the 3rd root of 27, which happens to be 3. No plus or minus because the root is a 3. So let's solve these equations with powers. Number 11, I'm always going to be using this PEMDAS backwards. So first thing I do is divide by 2 on both sides. X to the 4th is 81. So add, subtract, we couldn't do it. Multiply, divide, we divided. Now I deal with my exponents. I want to take a 4th root on both sides. That's how we say it. Not like square root 4, but like 4th root. So now the 4's will cancel, and I'll have x. And then you can do a couple things. If you don't know what the square root of 8 or the 4th root of 81 is, I can plug this into my calculator. 81 to the 1 over 4. Okay, if I do that, I get 3. But then I've got to remember that this 4 makes a difference. I have to have a plus or a minus. Number 12, again, PEMDAS backwards. I can't add this 2 right away because it's in parentheses. So what I have to do is take a third root on both sides. I get x minus 2 is equal to the third root of 10. And that third root of 10, if I plug it into my calculator, 10 to the 1/3, I actually get a decimal. If you get a decimal, you can actually leave it in just the radical form. So then I can add 2 to both sides, and I'll get x is equal to 2 plus the third root of 10. Notice we don't do plus or minus, because this time around I've got a 3. So a positive times a positive times a positive is going to equal positive, but not the negative one. So then this is my final answer. $13 is a lot like number 11, so if you want to pause the video and try it, you can definitely do that. We divide by 5 on both sides. I get y to the 4th is equal to 16. Take a 4th root on both sides, and y is equal to 2. But since it's a 4th root, I need a plus or minus. And number 14 is a lot like number 12. So again, if you want to pause the video and try it, do so. I'll take a third root on both sides. Y minus 1 is equal to the third root of 32. The third root of 32 we're actually going to break down in our next lesson, but for now, we can leave it just like it is. So add 1 to both sides, and we get y is 1 plus the third root of 32. Again, I don't do plus or minus because I don't have a square root or a 4th root or a 6th root. $15's in a little different form than we've seen so far, but we have seen these types of problems before. PEMDAS backwards, subtract 7 on both sides. I've got 3y cubed equals 21. PEMDAS backwards, now it's multiply, divide. Divide by 3 on both sides. Y cubed equals 7. Take a cube root on both sides, and y is equal to the third root of 7. It's not plus or minus because of the 3, because it's a third root, not an even root. 16, if I'm doing PEMDAS backwards, there's nothing to add, subtract, so I divide by 3. I get y plus 7 cubed is 28 over 3. And then I take a cube root. I get y plus 7 is the cube root of 28 over 3. Again, in the next lesson, we're actually going to learn what we do with that 28 over 3 in the third root. Because remember, we don't like to have radicals in the denominator of a fraction. So we're going to deal with that, just not today. Subtract 7 on both sides. And I get y is equal to negative 7 plus the third root of 28 over 3. So that's all we got for today. The main thing I want you to know is this. A to the m over n is power over root, and how to plug that into your calculator or how to find the root and then